Okay, hi class. It's the weekend, and this is a continuation of the assignment given out on Thursday. The day and the date are wrong on the assignment, but it was given out last week, and we're going to try to finish that up this weekend and turn that in on Monday. So what I'm going to do is complete the last three problems. We had a good work session on Friday. Sorry, a lot of you missed it, so this is a chance to catch up on that. Okay, so here we go. We're going to do this chemical equation right here. It's already balanced for you, and we're going to just answer the questions down below. One thing we do have to do, however, is to go ahead and get the molar masses of each of these compounds. All right, so let's go ahead and do that. Some students were telling me that this really wasn't enough space to write it, so I'll write it down below. So for sodium, again, you're not looking at 2 moles of sodium. You're looking at 1 mole. It is a molar mass. It's 1 mole. What is the mass of 1 mole? This 2 will come into play later on in the problem. So for this one, for sodium, it's 22.99 grams. For water, it's 18.02 grams. For sodium hydroxide, it's 40 exactly. And for hydrogen gas, it is 2.02. Those are all grams. Okay, this one goes there, and so forth. Okay, so those are your molar masses. Those translate from the world of grams, which we can measure with a scale, to the language that the chemical equation speaks, which is moles, which we can't possibly count. So that's what these molar mass conversions are used for. All right, so let's get going. How many moles of H2O are needed to produce 4 moles of NaOH? So the question is, how many moles of H2O? So you find H2O. This is the moles row up here, and this is the grams row, but it's asking us for moles. So it's asking how many of these. So we're going to put a question mark there. And you're starting off with 4 moles of NaOH. So right here is where moles of NaOH would be. So we're going to put a 4 there. All right, so all we have to do is make a single simple conversion. Keep in mind, you can only make conversions where you see arrows. So for example, we can't make a conversion from grams of water to grams of NaOH because there's no arrow between them. That would mean if we wanted to, you'd have to go up, over, and down. So in this case, though, it's just a single simple conversion. So what we're looking for is this. We put that way over on the left, and that is moles, unit of measure, and compound or substance, not always a compound. Okay, and over on the left is what we start with, and that's going to be 4 moles of sodium hydroxide. And then we're going to multiply. It's a single conversion, so I'm just going to put 1 box. So what this is saying is the relationship between this is these relate to each other, 2 moles to 2 moles. So what that means is we can either say that we have 2 moles of H2O, which should be mole right there, for every 2 moles of NaOH, or we have 2 moles of NaOH. I'll come down on screen here. For every 2 moles of H2O. And as you get better and better at these, you won't have to write out all of these like this. You'll be able to do these fairly quickly and start to do them, except for the actual math. You'll be able to do the whole thing kind of in your head. All right, so which one do we want to use? Well, we need moles of NaOH to cancel out, and we need to end up with moles of H2O at the end on top. So that means we're talking about this one right here. All right, so we're going to write 2 moles of H2O and 2 moles of NaOH. Okay, and there we have a cancellation of moles of NaOH with moles of NaOH. The last man standing is moles of H2O. So 4 times 2 divided by 2 just gives us 4. So that's called a 1-to-1 relationship. We have 1 mole of this, we have 1 mole of that. If we have 2 moles, 2 moles, 4 moles, 4 moles. 52 moles, 52 moles. It's just, that's a one-to-one relationship. You have one for each that you have, okay? All right, so that takes care of that one. I'm going to erase the numbers in the boxes here because I'm going to use these each time. And let's move on to the next problem. And this one wants to know how many grams of sodium are needed to produce 5.97 grams of H2, of hydrogen gas. So it wants to know how many grams of sodium. So we go up to sodium, come down, there's the grams row right here. So that's what we want to know, how many grams of sodium. And to produce a certain number of grams, 5.97 grams of H2. So here's H2, we come down here. So even though the chemical equation, I made this point before, even though the chemical equation is flowing from left to right, that's the way chemical equations move, our problem is going in the other direction. We know what we want to produce. We know what we want to get out of the reaction in terms of hydrogen gas. So what we have to do is come up, over, and back down to figure out how many grams of sodium we have to put in. What do we have to start with in order to get that many grams of H2? So again, the procedure is to come up through this molar mass to get moles of hydrogen gas. Then you go directly from hydrogen gas to sodium. You have to move laterally. Laterally is sideways. You always have to move laterally within the chemical equation. You cannot move laterally down here because there are no arrows down there. So you need to get from here to here. And then once you know how many moles of sodium, you come back out using this molar mass conversion right here. Okay, so let's get this started. So we're going to start off way over here on the right with 5.97 grams of H2. And we need to end up way over here and keep a lot of space because you're going to need 3 conversions for this. We just saw that. Way over here, you're going to need some number of grams of sodium. And I'm going to need 3 conversions. We just showed you that. So there's the gas to moles of hydrogen gas. The next one is going to get you from moles of hydrogen gas to moles of sodium. And then the final one is going to get you back out of the chemical equation into our world, which is moles of sodium back into grams of sodium. All right. So see if we can do these without necessarily writing out all of these, but I'm going to do it here. So I'm going to come up to the top and write my ratios for actually for hydrogen first, okay? So what it's saying is, okay, and we're dealing with this problem right here. I'm saying that there's 1 mole of H2 for every 2.02 grams of H2. So that's a true statement. Or there's 2.02 grams of H2 for every 1 mole of H2. Okay. So which of those am I going to predict? I got to put one of those in this first box right here. I need grams of H2 to cancel out. So that would be this one right here. That's got grams of H2 on the bottom. Let me do it there. Grams of H2 on the bottom. And so that's going to be the one that needs to go on the bottom. So it's going to be 2.02 grams of H2. And up on top, I have the 1 mole of H2. Okay. Next one, we've got to now get from moles of H2, that's where we're sitting right now, over to moles of Na. And you can see there's 2 moles of Na for every 1 mole of H2. So I'm going to, let me create a little space here. I'm going to write that right here. So there's 1 mole of H2 for every 2 moles of Na. Or there's 2 moles of Na for every 1 mole of H2. Okay, so which one are we going to want in this second position right here? Well, we have moles of H2 on the top. That means we need moles of H2 on the bottom. So that means we're going to use this one right here. So we're going to write 1 mole of H2. And up on top, it's going to be 2 moles of Na. Okay. Alrighty, and so we can go ahead and show our cancellations, by the way. Grams of H2 cancels out with grams of H2. That was the first step. And moles of H2 cancels with moles of H2. That's the second step we just did. So now we're ready for our final step. And there's two ways you can reason this out. It's either got to have moles of Na on the bottom. You could reason it out that way because of this. Or the last man standing on the top has got to be grams of Na. So let's go ahead and write our last molar mass conversion. And we can see that it's either 1 mole of sodium over 22.9 grams of sodium or 22.9 grams over 1 mole. Well, we just identified which one it has to be. It has to have the moles of Na on the bottom. So it's 1 mole. Don't get confused. It's not 2 moles. It's 1 mole. It's a molar mass conversion. It's that number right there. 1 mole of Na, and on top is the 22.99 grams of Na. Okay, so moles of Na cancels moles of Na, last man standing right there. Now we can go ahead and do the math. And I'll do that without stopping the tape. It's 5.97 times 1 times 2 times 22.99 divided by 1 divided by 1 divided by 2.02. And what that gives me is 135.9. I'm not worrying about significant figures right now. You got enough to think about doing these problems. So let's just leave it at that. That's how many grams of sodium it would take to produce 5.97 grams of hydrogen gas. Okay, we're now on to part C. And it's how many grams of water, H2O, is required to produce 3.32 grams of sodium hydroxide. So let's come up here. Let's just look at the diagram. So it's asking how many grams of water, here's water, there it is right there, it is needed to produce 3.32 grams of sodium hydroxide. There's sodium hydroxide, there's the grams box, so that's 3.32. So again, as I said last time, even though this reaction is proceeding from left to right, our problem is going in the other direction. It's saying how much water do I need to get this much? So I start off with this much, and then I work backwards to figure out how much water it takes to do that. So what's our order here? We're going to go from grams of sodium hydroxide, use the molar mass of sodium hydroxide to get us moles of sodium hydroxide. Then from moles, we're going to go to moles of water. And then from moles of water, we're going to come back out of the equation back to our world and tell us how many grams we would have to get, how many grams we'd have to get out of the bottle of water to do this reaction. All right, so let's go ahead and write way over here on the right is our question mark. It's grams of H2O. And way over here on the left, and let me try to keep it on screen. I'm going to have to move the paper up and down. Way over here on the left is going to be 3.32 grams of NaOH. Okay, and then I'm going to draw my boxes. One of the reasons I draw the boxes is to make sure that I'm giving myself enough space here, because if I find I can't draw 3 boxes, and I'm a little tight right here, you can see, as far as drawing boxes, then maybe what I need to do is do something like this. Erase that a little bit. There goes my eraser. Okay, so just draw a little shorter line right there. And there's my third box right there. Okay, so that's the only real reason for drawing the boxes. Okay, here we go. So now we're starting here. And I'm not going to write down the conversion ratios. I want you to get to the point where you're kind of you're doing them in your head. You can either say there's 1 mole of sodium hydroxide over 40 grams of sodium hydroxide, or 40 grams of sodium hydroxide over 1 mole of sodium hydroxide. So which one do we need on the bottom in that of those two relationships? The answer is we need grams of sodium hydroxide to cancel, so we put the 40. I'm going to be a little lazy and avoid the decimal points there. 40 grams of sodium hydroxide. And on top, therefore, we have our 1 mole. It's a molar mass conversion. It's always 1 mole. And grams cancels with grams up here, and we've taken care of our first conversion. Now we need to go from 2 moles of sodium hydroxide to over here to 2 moles of H2O. So you can put 2 moles of H2O over 2 moles of sodium hydroxide, or 2 moles of sodium hydroxide over 2 moles of water? Well, we need to have moles of sodium hydroxide on the bottom because the moles, right here we have moles of sodium hydroxide, so we need moles of sodium hydroxide down there. So now here is where you do actually write the moles. It's when it's actually, you're actually moving through the equation like that. So it's 2 moles of sodium hydroxide. And up on top we have 2 moles of water. Okay? And we go ahead and do our cancellation as we go along. Moles of sodium hydroxide there and there. And that leaves us with 2 moles of water on top. Now we have to make our third conversion. We're going from moles of water back out into our world, into grams of water. So we can either write 1 mole of water over 18.02 grams of water, or 18.02 grams of water over 1 mole of water. Which one are we going to want? Well, this tells us we need moles of water on the bottom. This tells us we need grams of water on the top. So that answers that question. So it's 18.02 grams of water. And on the bottom, it is 1 mole. Again, it's a molar mass, so we're using 1, not 2. 1 mole of water. And moles of water cancels moles of water. Last man standing right there. So now you go through and you crunch the numbers. So everything on top multiplies, divide by everything on the bottom. So 3.32 times 1 times 2 times 18.02 divided by 1 divided by 2 divided by 40. And that will give us our answer. And that I get 1.49. And that's our answer. So again, what does that mean? How do we interpret that? It means it takes 1.49 grams of water, 1.49 grams of water to produce 3.32 grams of sodium hydroxide. That's what that's telling us. Okay, D, how many moles of sodium are required to make 2.59 grams of sodium hydroxide? Okay, so let's go back up to our diagram here. Let me erase our old numbers. And how many grams, or how many moles of sodium? So we find sodium, it's right here, and moles is right here, and it's asking us how many, so that's our question mark. Of sodium are required to make 2.59 grams of sodium hydroxide. So here's sodium hydroxide. We have to come down to the grams box down there, and it's 2.59, so I'm going to write that. Grams of sodium hydroxide. So how many conversions is this? Well, we need to make 1 conversion to get from our world inside the chemical world. So they're using the molar mass conversion of sodium hydroxide. And then once we're inside, we need to make a conversion inside the equation from moles to moles. And that's what it's asking us for, so we end right there. So that's 2 conversions. All right, so let's start off way over here on the right. And that's going to be moles. And mole is spelled in chemical equations without the E, of sodium. And 2.59 grams of NaOH. And we're going to draw 2 boxes because we said we needed 2 conversions. Okay, so there we go. All right, so the first one is a molar mass conversion. It's taking us from grams into the equation into moles here. So we can say there's 1 mole of sodium hydroxide for every 40 grams sodium hydroxide, or 40 grams sodium hydroxide for every 1 mole. So let's come over here. We need grams of sodium hydroxide to cancel out. So which one of those 2 are we going to use? And yes, we're going to use 40 grams of sodium hydroxide for 1 mole. Molar conversion, 1 mole always. Molar mass conversion, excuse me. Okay, 1 mole always. Okay, so grams cancels with grams of sodium hydroxide there. And now we're ready for our final conversion. And we're simply going moles to moles, 2 moles of sodium hydroxide over 2 moles of sodium, or 2 moles of sodium over 2 moles of sodium hydroxide. We need moles of sodium hydroxide to cancel, so we're going to do the 2 moles of sodium hydroxide on the bottom and the 2 moles of sodium on the top. Cancel moles of sodium hydroxide. Moles of sodium is the last man standing. That's the unit of measure at the end. So now we have the units lined up. We're ready to pull out our calculator. 2.59 times 1 times 2 divided by 2 divided by 40. And that gives us 0.64 moles of sodium. 0.064 moles of sodium. That's our answer right there. Okay, next up, how many grams of hydrogen gas will be produced by 5.67 moles of water? So let's go back up to the diagram. Let's erase all the old stuff. So how many grams of H2 gas? So here's H2 and grams is down here, so that's our question mark. It's asking how many. And it's produced by 5.67 moles of water. There's water, and the moles row is up here inside the chemical equation. So that's 5.67. So what's our path? And I saw a few students, and of course this happens when you're new at this, trying to do this. Go this way, like that. You can't do that. You can do this, but you're not allowed to do this because there's no arrows there. You can't go laterally outside of the chemical equation. So you have to go from here to here, and then from here down to there. Okay, so let's go ahead and set up our equation. On the right side, we have grams of hydrogen gas. And on the left side, we have 5.67 moles of water. And we see from what we just saw up there that there's 2 conversions to get there, 2 boxes. Okay, all right, so the first one is going to be moles to moles. We have to go this way. So there's 2 moles of water over 1 mole of H2, or there's 1 mole of H2 over 2 moles of water. All right, so which one do we need? Well, we need moles of water to cancel out, so we're going to put 2 moles of water on the bottom and 1 mole of hydrogen gas on the top, and cancel the moles of water. Okay, our last conversion is a molar mass conversion. It's taking us from moles of hydrogen to grams of hydrogen. So there's 1 mole of hydrogen over 2.2 grams of hydrogen, or there's 2.2 grams of hydrogen over 1 mole of hydrogen. Which one do we need? Well, we need moles of hydrogen to cancel out because of, whoops, I am off screen. I am sorry about that. Try to remember to keep that on screen. So we need moles of hydrogen to cancel out. So that has to be on the bottom. We need grams of hydrogen to be the last man standing on the top. So that's going to put 2.02 grams of hydrogen over 1 mole. It's a molar mass, so it's 1 mole, always in a molar mass conversion of hydrogen. Okay, so I hope you caught up with where I was. I had done the other cancellation before. So this is moles of hydrogen cancels moles of hydrogen. Grams of hydrogen is what's left over. So now what we're going to do is we're going to multiply everything on the top, divide by everything on the bottom. So it's 5.67 times 1 times 2.02 divided by 1 divided by 2, and that's going to give us 5.73, we'll call it. Okay, there we go. All right, be a little more careful about staying on screen here. Okay, next up, our last question for this particular equation is how many moles of sodium hydroxide are produced by 6.8 grams of water? So let's go back up to the diagram. So we want to know moles of sodium hydroxide. So here's sodium hydroxide, here's moles. There's the moles row, so that's the question mark, how many? And we're going to start off with 6.8 grams of water. So there's water, the grams box is down here for water, so that's 6.8 grams. So our path is going to be the molar mass conversion from grams of water to moles of water, and then from moles of water over to moles of sodium hydroxide. So it's a two-step, two-conversion process. Okay, so let's start off on the right-hand side with what we don't know, which is moles of NaOH. And over on the left, we have 6.8 grams of water. And two conversions means we need two boxes. Okay, so where are we going to start? We're going to go into the equation right here using molar mass of water. So we either have 1 mole of H2O over 18.02 grams of H2O, or 18.02 grams of H2O over 1 mole of H2O. Well, we need grams to cancel out because we have it right here. So it's going to be 18.02 grams of H2O. And it's a molar mass conversion, so it's always 1 mole. Grams, H2O cancels. Okay, now we have to go from moles of H2O to our final answer of moles of sodium hydroxide. And we see that's 2 moles of water, H2O, over 2 moles of sodium hydroxide, or 2 moles of sodium hydroxide over 2 moles of water. We have moles of water on top here. We need moles of water on the bottom. So it's 2 moles. Okay, and we need 2 moles of sodium hydroxide on the top, which is our last man standing. Okay, so moles of water cancels moles of water, last man standing. So now we can do our math. So it's 6.8 times 1 times 2 divided by 2 and divided by 18.02. And that gives us 0.38. And that's our answer. And that takes care of this particular equation. Okay, we're off to problem number 4. This is a photosynthesis reaction you may recognize from biology. Carbon dioxide plus water plus, of course, light, you need light energy, is going to produce a sugar and oxygen. So that's what plants do. So let's go ahead and get started. I've already written the molar mass conversions. Hopefully this is very easy for you by this point. If it's not, come in and let's practice, okay? There's no shame in saying I still don't get how to do these things. You got to get them down, okay? This is critical that you learn this. Come in and let's work on a few of them. Okay, here we go. A, how many moles of CO2 are needed to produce 5 moles of sugar? Okay. So how many moles of CO2? So here's CO2, here's moles, so that's a question mark. And it's asking for 5 moles of the sugar here, so there's the 5 there. So this is a straight across moles to moles conversion. We start inside the chemical equation, we end inside the chemical equation. So over here, it's going to be a 1 conversion problem. So it's moles of CO2. And over here, it's 5 moles of sugar. And as we said, it's 1 conversion, so 1 box. Okay, so we can either say that there's 1 mole of sugar over 6 moles of CO2, or there's 6 moles of CO2 over 1 mole of sugar. Which do we want? I think we all are, I hope, catching on to this. Moles of the sugar, so we have to have that on the bottom. So that's 1 mole of sugar. And on top, it's got to be 6 moles of CO2. Moles of sugar cancels out, and you have 5 times 6 is 30 moles of CO2 are required to do that. In other words, you need 6 times as much CO2 as you want to produce moles of sugar. So if we want to produce 5 moles of sugar, we need to have 6 times that many, or 30 moles of CO2. Okay, let's go on to B. How many grams of carbon dioxide are needed to produce 2.23 grams of oxygen? So let's fill that in here. So carbon dioxide, they want to know grams. So carbon dioxide come down to grams, and it's how many, that's the question mark. And you want to know how many are needed to produce 2.23 grams of oxygen. Here's oxygen over here. You got to go down to the grams box. 2.23 grams. So take a second. What's the path you're going to do to get from 2.23 to the question mark? Okay, so you're going to do a molar mass conversion of oxygen to make it turn into moles of oxygen. Then you're going to go from moles of oxygen over to moles of carbon dioxide. And then you're going to come back out using the molar mass conversion for carbon dioxide to get the total grams of carbon dioxide that it will take to produce 2.23 grams of oxygen. Okay, so let's write this over on the right. Is our question mark is grams of CO2. Way over here, because it's 3 conversions, is going to be 2.23 grams of oxygen gas. Then you're going to multiply by 3 boxes. And if you're starting to really get this whole process, then start trying to do it without quite as much writing and scaffolding. Try to see how much you can kind of do in your head. It'll come naturally eventually, but kind of push yourself a little bit. But don't sweat it if you need to write all the boxes and all the ratios and everything else down. Okay, here we go. 2.23 grams of O2. So there's 1 mole of O2 gas. This is 2 O2 atoms stuck together for every 32 grams of O2 gas, or there's 32 grams of O2 gas for every 1 mole of O2 gas. So I have to have grams on the bottom. And it's 1 mole. It's a molar mass conversion. Okay, so it means you use that many moles, not that many moles. All right, grams of O2 cancels, and now we're ready to go from moles of O2 to moles of CO2. Well, there's 6 moles of CO2 for every over 6 moles of O2, or 6 moles of O2 over 6 moles of CO2. We want moles of O2 to cancel out, so that's got to go on the bottom. So now you write the 6. And then same thing for carbon dioxide, happens to be 6 as well. And I should have written moles of CO2. Okay, so moles of O2 cancels out. And now we're sitting right here. We need to get back out to get to our final answer. So we're going to use the molar mass conversion for CO2. So there's 1 mole of CO2 for every 44.01 grams. CO2, or 44.01 grams of CO2 for every 1 mole of CO2. Which one are we going to use? Well, we have moles of CO2 on the top there. So it's going to be 1 mole because it's a molar mass conversion. And on top is 44.01 grams of CO2. Boom. Okay, moles of CO2 cancels there and there. Last man standing. Boom. So now you can do your math. So we start off with 2.23 times 1 times 6 times 44.01 divided by 1 divided by 6 divided by 32. And I get 3.7, call it. After beating you up about significant figures, we're not going to worry about that right now. Okay, there you go. That's your answer for that. All right. Okay, next up, how many moles of H2O is required to produce 4.83 grams of O2? So we start with moles. It's how many moles of H2O. So here's moles H2O, question mark. That's what we want to know. is required to produce 4.83 grams of O2. So here's O2, and we come down to grams, and that's going to be 4.83. So we need to get from grams of O2 to moles of O2, and then cross over here to moles of H2O, and we'll be done. So we're going to start over here with moles of H2O. And way over here is 4.83 grams of O2. And we see that it's two conversions, so we're drawing two boxes. Okay, so what do we got to do? Well, we got to do the molar mass to get us from grams into moles. So it's 1 mole of O2 for every 32 grams over 32 grams of O2, or 32 grams of O2 over 1 mole of O2. This says we need grams of O2 on the bottom. So we're going to put 32 grams of O2 on the bottom, and it's a molar mass, so it's 1 mole of O2 on the top. Grams of O2 cancels. Now we need to go from moles of O2 to moles of H2O, so it's 6 O2 over 6 H2O, or 6 H2O over 6 O2. We need moles of O2 on the bottom. No, moles of O2 on the bottom, so it's going to be 6 moles of O2, 6 moles of H2O. Moles O2 cancels, moles O2 cancels, last man standing. And so we can do our math, and that's going to be 4.83 times 1 times 6 divided by 6 divided by 32, and that gives us 0.15. Okay, how many moles of O2 are required to make 1.52 grams of sugar? The sugar, by the way, is glucose. It's the sugar produced in photosynthesis by plants. It's a simple, very simple sugar. Okay, so, all right, so how many moles of O2? So we find O2, it's right here, and the moles, it's right there, is a question mark. Grams of sugar. So here's sugar, we come down to grams, and we have a specific number actually, so let me write that down. 1.52 grams. So how are we going to get from here to here? We got to go up into the equation and then move over. So we're going to do a molar mass for glucose and end up over there. So let's write our equation. It's some number of moles of O2. It's going to be two conversions, and we're going to start with 1.52 grams of this times a box times another box, and that'll get us to our answer. Let me get on screen again here. Okay, so there we go. All right, so first thing we're doing is going from here to here. 1 mole of glucose over 180.18 grams of glucose, or 180.18 over 1 mole. Which one do we want? We need grams of glucose on the bottom, so that's going to be 180.18 grams. And on top, it's a molar mass, so it's 1 mole. Okay, there you go. All right, now we need to move from moles of glucose to moles of oxygen. That'll be our final answer. So there's 1 mole of glucose over 6 moles of oxygen, or there's 6 moles of oxygen over 1 mole of glucose. Which one are we going to need? Well, we need moles of glucose on the bottom here. So it's so again, now we're using these numbers because it's mole to mole conversion. So it's 1 mole and on top it's going to be 6 moles of oxygen. Okay, so grams of glucose and grams of glucose canceled over there. Moles of glucose and moles of glucose cancels there. Last man standing, moles of oxygen. Do the math. Times 1 times 6 divided by 180.18 divided by 1. And that gives us 0.05. Okay, all right. Okay, part E, how many grams of oxygen will be produced by 5.67 moles of carbon dioxide? So we come up here, it's asking us how many moles of oxygen. So here's oxygen, here's the moles box, that's the question mark, and it's grams of carbon dioxide, 5.67 to be exact. Excuse me, 5.67 moles. I muffed on that one. So 5.67 moles of carbon dioxide. So that's going to go here. So that's going to make it an easy problem. So it's a single conversion, moles of carbon dioxide to moles of oxygen. So our question mark is moles of oxygen. And our we're starting with 5.67 moles of CO2 times 1 box. That's all we need. Okay, so we either have 6 moles of CO2 over 6 moles of O2 or 6 moles of O2 over 6 moles of CO2. You can see that's called a 1-to-1 relationship. Okay, so it's moles of CO2 on the bottom, so 6 moles CO2 and 6 moles of O2. And moles CO2 cancels, and you end up with moles O2 on the top. So it's 5.67 times 6 divided by 6, so you get exactly that same number of moles. Okay, there you go. All right, and let's just erase and keep rolling right here. And the last problem we have is a moles to grams problem. Okay, so here we go. So how many moles of H2O are needed to produce 8 grams of glucose? So how many moles of H2O, so it's asking how many moles here is to prove 8 grams of glucose. So there's 8 grams right there. So we need to go from, we're going from the number to the question mark. So we go up through the molar mass of glucose, and then from moles of glucose to moles of water. And that gets us to our final answer. So let's go ahead and do that. So it's moles of H2O. And way over here, it's 8 grams of glucose. And it's going to be 2 conversions. We had to go through 2 different places there. So it's 2 conversions equals, okay. All right, so the first one is going to be a molar mass. We have to go from grams of glucose to moles of glucose. So it's 1 mole of glucose over 180.18 grams of glucose, or 180.18 grams of glucose over 1 mole of glucose. Which one do we want? We need grams of glucose on the bottom, so we're going to put 180.18 grams of this stuff. And that's a molar mass, so it's always 1 mole. Okay, grams of glucose cancels, and now we do our final conversion, which is moles to moles. 1 mole of glucose over 6 moles of H2O, or 6 moles of H2O over 1 mole of glucose. Which one do we want? We want moles of glucose up here, so we need moles of glucose on the bottom. So that's going to be 1 mole. That means we've got 6 moles of H2O up on the top there. So moles of glucose cancels here and here. Last man standing is moles of H2O. Okay, so it is 8 times 1 times 6 divided by 1 divided by 180.18. And what that gives us is, that's not what it gives us. That gives us 0.27, 0.27. Okay, there you go. Okay, and that takes care of this photosynthesis reaction. Okay, let's get going here. Last problem. Potassium hydroxide is put in hydrobromic acid, one of the 6 strong acids that we'll learn about in the not too distant future, and it gives us potassium bromide and water. So let's go ahead and let's figure out what the molar masses are. Let's go ahead and do that, and I will actually give those to you here, but be sure you can know how to do this, all right? Okay, so you can see magically they appeared here. Here are the molar masses for each of these compounds right here. So let's go ahead and get started with this. So how many moles of potassium hydroxide are needed to produce 10 moles of water? So we're starting out with moles of KOH. That's the question mark here. And we want to get the moles of water. So that's water. There's the, 10 moles. We actually have the number of that. So that's 10. So that's a single conversion from moles to moles. Oh, we didn't balance the equation, but it looks like it's already imbalanced, doesn't it? And I think everything's good there, isn't it? Bromine, 2 hydrogens, an oxygen, potassium, yeah, everything's good. But let's write the coefficients. It's not normally done, but I want us to do it in this class to be sure we see those numeric relationships between moles. Okay, all right. So we start off with what we don't know over here. That's moles, KOH. And what we know over here is 10 moles, H2O. And we just have one box. Okay. So we have 1 mole of KOH over 1 mole of H2O, or 1 mole of H2O over 1 mole of KOH. So we need moles of H2O on the bottom to cancel with this. So 1 mole and 1 mole. Kind of nice to end with an easier problem. You don't have to, your brain's a little tired. So moles H2O, moles H2O. So it's 10 times 1 divided by 1 is 10. Okay, so it's a 1-to-1 relationship. Okay, you get the same number out as you put in there. All right, let's keep going here. Let's erase what we have up here. Good. And let's keep going. So next, how many grams of KOH? So right here it's asking us how many grams. There's grams down there, and it's on how many are needed to produce 12 grams of KBr. So right here is 12 grams there. So while the equation, again, is flowing from left to right, our problem is going in the other direction. We want to produce this, and we need to have to know how many grams of KOH we're going to need to produce potassium bromide. So we got to go up into the equation, come across, and come back down. All right, so let's go ahead and do that. This is a 3 conversion problem. And we're trying to find grams of KOH. All right, so there we go. Okay, so what do we got? 12 grams of KBr. So there's 1 mole of 1 mole of KBr for every 119 grams of KBr, or 119 grams of KBr for every 1 mole of KBr. So it's 119 grams KBr, and on top we've got, it's a molar mass conversion, so it's always 1 mole. Okay, so grams KBr is going to cancel there and there. Now we got to go moles of KBr to moles of KOH. This almost seems a little silly, but Moles of KBr goes on the bottom, so it's 1 mole KBr, 1 mole KOH. Cancels, cancels. Now we've got to come out of the equation from KOH moles of KOH to grams of KOH using the molar mass conversion. So it's either 56.11 grams of KOH over 1 mole of KOH, or 1 mole of KOH over 56.11 grams of KOH. Well, it looks like we need moles of KOH on the bottom. So that's a molar mass, so it's 1 mole. And up on top is the mass. And so moles of KOH cancels, and grams of KOH is the last man standing. So we're ready to do the math. And I think you know how to do it by now, so go ahead and do that. And I get 5.6. Okay. Next up. Okay, next up, how many grams of H2O can be produced from 5.43 grams of HBr? So the question mark is grams. H2O is down here. And what we're starting with is grams of HBr. So right there, so that's so that is a 5.43. And again, identify the path to get from here to here. You got to go up, over, and back down again. Okay. So what we're looking for is grams H2O. I'm going to get on screen. And what we're starting with is grams of it's 5.43 grams of hydrobromic acid. Okay, and this is going to be grams to grams, so you just saw it, it's going to be 3 conversions. Okay, so first we have to go from grams of HBr to moles of HBr, so it's 1 mole of HBr over 80.19 grams of HBr, or 80.19 grams of HBr over 1 mole of HBr. We need grams of HBr to cancel, so they have to go on the bottom. So it's 80.91 grams HBr, and it's a molar mass, so it's 1 mole of HBr. And there we go. I'll be sure I'm on screen. Sorry. Okay. Now we need to go moles to moles. So from HBr to H2O. Okay. So it's 1 to 1. That makes things really easy for us. So we need moles of HBr on the bottom. So it's 1 mole of HBr and 1 mole of H2O. Moles of HBr cancels, and now we're at our final conversion. It's a molar mass of water from moles out to grams again. So we can have 18.02 grams of water over 1 mole of water, or 1 mole of water over 18.02 grams of water. Well, we need moles of water on the bottom, so it's a molar mass, it's 1 mole. And grams is 18.02 grams. Okay, moles of water cancels and cancels. Grams of H2O is left, and now you run your numbers. And I get 1.21. However you want to write it, I don't care in this case. Okay, there you go. All right. Next up. Okay, we've got how many moles of KBr can be made from 6.3 grams of HBr. So we want to know moles of KBr. There it is right there, moles KBr. And grams of HBr is 6.3. Okay, so our path is to go from grams to moles of HBr and then move over to moles of KBr. So let's go ahead and do that. So our question mark is moles of KBr. And we start off with 6.3 grams of HBr. And it's two conversions, 1, 2, we saw up there. So it's two boxes. Okay. All right. So first one is HBr. We got to go from grams to moles using molar mass. So it's 80.91 over 1 mole, or 1 mole over 80.91. We need the grams on the bottom. So it's 80.91 grams HBr, 1 mole HBr. Grams of HBr cancels. And now we're going to do the moles to moles. 1 HBr for every 1 KBr. So it's 1 HBr over 1 KBr, or 1 KBr over 1 HBr. Hopefully you're getting a little faster at this. I'm talking a little faster. So we need moles of HBr on the bottom. It's a 1-to-1. And that means there's 1 mole KBr on top. So this cancels, last man standing. And it's 6.3 times 1 times 1 divided by 1 divided by 80.91. So you can run that real quick. And I get 0.078. All right, there you go. Next, how many grams of KBr will be produced by 0.67 moles of HBr? So let's go ahead and write our equation first this time, 0.67 moles of HBr, and eventually, you don't need to use the diagram up above, and it's grams of KBr. So we're going grams to moles. That tells me right away, and you've noticed this, that that's going to be two conversions. So grams KBr. So that means we're going to multiply by 2 boxes. All right. And let's go up and take care of that. Let's erase what we had before. So we start out with 0.67 moles of HBr. So that's right there. And we want to come out with grams of KBr. So that's down here. So I think we're just going in the opposite direction of the last problem. So we start here. We first have to make our moles to moles conversion and then our molar mass conversion to get outside of the equation again. All right, so let's go ahead and do that. So first, moles to moles, it's 1-to-1. So we can see clearly we have the moles of HBr have to be on the bottom. So 1 mole and 1 mole of the other guy. This guy cancels. If I'm off screen, I am off screen again. Excuse me. So that guy cancels. That's the way you had to write it to get it to cancel. Okay, now we have to go from moles of KBr out to grams using molar mass. So it's 119 grams KBr over 1 mole KBr, or 1 mole KBr over 119 grams of KBr. Since we have moles of KBr on the top here, we have to have it on the bottom here. It's a molar mass, so it's always 1 mole. And up top's 119 grams KBr. Moles KBr cancels there and there. Last man standing is grams of KBr. So now we just crunch the numbers, and this one is just 0.67 times 119, and that gives us 79.7. Okay, one more to go on this. We're not going to beat 1 hour on this video, but remember, you can always skip around as you need it. Just skip to the final answer if that's all you want to see. And that's it. So let's do one more. Erase what I have up here. Okay, so this one. How many moles of KOH? So that's what we want to find out at the end. So it's moles, KOH, and it's starting off with 6.8 grams. So by now you recognize moles to grams or grams to moles as two conversions of water. So that means I'm going to need 2 boxes. Go up top anyway in case you didn't see that. So we're starting off with grams of H2O right here. So there's H2O, there's grams. It's 6.8. We're going to end up with moles of KOH. So up here is KOH and there's moles. There's the question mark. So to get from here to here, we have to use molar mass to get moles of water and then go across the equation to get moles of KOH for our final answer. Okay, so here we go. So the molar mass of water is 1 mole water over 18.02 grams of water, or 18.02 grams of water over 1 mole. We need to have grams on the bottom to cancel with this, so it's 18.02 grams H2O and 1 mole H2O. Grams cancels right there. Now we need 1 molar, it's moles to moles. And as we've seen throughout this problem, everything is 1 to 1. So 1 KOH over 1 H2O, or 1 H2O over 1 KOH. H2O is on the top, so we need it on the bottom. This cancels with this. Last man standing. So 6.8 times 1 times 1 divided by 18.02. Let's go ahead and do that. And I get 3.37.38. How about that? Okay, and there you go. All right, so a lot of problems, but this is a critical skill, guys. So it's just grinding it out, and hopefully this is starting to become intuitive to where you don't need all these boxes and conversion ratios. You're starting to do a lot of that, just cranking that out on the calculator. And that's it. So we'll turn this in on Monday. It's the only assignment you had. Don't forget to study for your quiz on the second set of the ions on that orange sheet. That'll be your quiz on Monday. So we will see you then.